Hello there, you are welcome. I am Uncle Agbaje. This is a video series that I am doing based on the lesson plans, the unified lesson plans of the Lagos State Universal Basic Education Board, LASUBEB, taking on the lesson topics in mathematics for Basic 6. And if you're a teacher looking to gain an insight into how to teach a mathematics topic in primary school, then this is the place you're supposed to be. So, this week we have been looking at estimation and approximation. In the last video, we talked about what approximations are. We looked at a new method for approximating numbers. I'm sure that you made a lot of sense out of that, and if you have not watched that video, then you probably need to watch estimation and approximation 1. Okay, so in this lesson, we're going to be looking at a special case of approximating numbers. We're going to be looking at situations where the digit after the round-off position is 5, or where the digit at the round-off position itself is 9, and how we're going to handle those kind of scenarios. So just stay tuned. So in the last lesson, we looked at a general method for rounding off numbers. For example, if you have to round off 6,278 to the nearest 100, we just identify the 100 digit, that is 2, so that forms our lower bound, 2 in the 100 place, and of course the next 100 will be 300, that forms our upper bound. It will form a mid value, 200, 300, the mid value will be 250. So we have to determine if the number that we're examining falls on the left of the mid value or on the right. In this case, 278 falls on the right, so it is closer to 300. So in the original number, which is 6,278, we replace that 278 with the 100 that is closest to it. We're going to have 6,300. This is our approximate value to the nearest 100. Okay, so what if the number that we want to examine falls directly on the mid value? I mean, when it is a mid value, it is equidistant from the lower bound and the upper bound. The distance between the lower bound and the upper bound is just the same. So where do we go? Well, there are two ways of handling this. Let us look at an example. This question says that we are to round off 485 to the nearest 10. In this case, the 10th digit is 8. We're just going to put 8 tenths, which is 80, as lower bound, and 9 tenths. The next 10 after 80 is 90. The mid value is 85. But the number that we want to examine itself in this case is 85. Falls directly on the mid value. So, do we go to the left or do we go to the right? Equal distance. Well, like I said, there are two ways of handling this. Standard estimation rules says that we should always go to the upper bound. So when you have a value that is exactly on the mid value, round it off to the upper bound, and that means that 85 will always be rounded off to 90, which means that 485 will round off to 490. That's standard rule for estimation problems of this nature. And if you want to teach children in primary school, then this is a good rule to teach them. When the value is exactly on the mid value, the number is exactly on the mid value, round off to the upper bound. But then there are other rules to handling situations like this. There is what we call the round half to even rule, and sometimes you might come across this in textbooks. So let me just take you through it so that it doesn't come as a shock whenever you see it. It's also a valid rule. Okay, so the round half to even, what does it say? If every time we have to round off numbers that are in the mid value, the halfway line, we always have to round it off to the upper bound. Then along the line, if we're working with large numbers or large data sets, we're going to be creating a sort of bias in the data set. So it is better to always have a way of reducing the kind of bias that we're giving to the upper bound. So sometimes we round to the lower bound and sometimes we round to the upper bound, and this is where the round half to even rule comes in. Let's take a look at that question again. 485 to the nearest 10. 485 to the nearest 10 again. The lower bound is 80, the upper bound is 90, the mid value is 85, and the number we're considering is 85 too. Okay, so of course we can always put 480, 485, 490. So it doesn't really matter as long as we're doing the correct thing. Okay, so what does the round half to even rule says? The digit in the tens place, which is the place value that we're considering, Is it an even number? If it's an even number, then you round it off to the lower bound such that the 10th digit must be an even number. If we round it to the upper bound, it's going to be a odd number in the 10th place. So we always round it to make sure that in the place value that we're interested in, the number there is even. So in this case, the round off to even rule says that we have to go back to the lower bound. So I'll take that again. If the digit in the place value that we're considering, if it's an even number digit, then we round to the lower bound, or whichever of the bounds that has an even number in the place value that we're considering. In this case, the place value is the 10th place value. This has 8, which is an even number in the 10th place value. This has 9, which is an odd number. So we're going to go back to the lower bound. Let's look at another example. So in this case, for the round off to even rule, 485 is going to be approximately equal to 480, so that we can have an even number in the 10th digit, because we are rounding off to the nearest 10, always to the even. Let's look at another one. This says 4.35 to the nearest 10th. Here, in the 10th position, the digit is 3. So we're going to have 3 tenths, which is 0.3. We can write 0.30. And the next tenth after that is 0.40. So of course we can put 4 before them. And then the mid value is going to be 0.35. We put 4. So this is the mid value. Incidentally, the number we're considering is also 4.35. So we're going to consider the lower bound and upper bound. Which one has an even number in the 10th position, which is the place value that we're considering. So this has an odd number in the 10th position, but this has an even number in the 10th position. So in this case, the nearest 10th that we're going to be selecting is 4.40, because that's the one that has even number in the 10th position. So in this case, we're going to be rounding this off to the upper bound. So we say 4.35 is approximately equal to 4.40. But that's when we're using the round off to even rule. But when we're using the standard rule as well, it will also go to the upper bound, because that says that whenever you are at the mid value, always go to the upper bound. So round off to even rule means whenever you have to consider a place value, check each of the lower bound and upper bound, whichever one of them has an even number in the position you want to. Whichever of them has an even number in the place value that you're considering, that is the one that you round off to. So sometimes it could be the lower bound, sometimes it could be the upper bound. I believe that this is clear enough. Okay, so just to check whether you get what we're saying, let's see whether you're going to do this correctly on your own. You can pause the video whenever you want to do it, and then check your answer afterwards. Alright, here is one for you to do all by yourself to check whether you understand what we've been discussing so far. We have to round off 165 and 15 to the nearest 10. You can use the standard rule. You have to use the round off to even rule as well. Let's see the answers that you get. Pause the video, do this, and then click play to continue. Alright then, what are the answers that you got? Well, for 165, this lower bound is 160 and then 170. And for standard rule, we just round off to the upper bound. So that's 170. But for the round off to even rule, the digit in the lower bound for the 10th digit in the lower bound is the one that has the even number, so we round it off to 160. But for 15, the lower bound is 10, the upper bound is 20. For the standard rule, we round up to the upper bound, and that is 20. For the round off to even rule, however, in the 10 position, we have the even number in the upper bound, so we round off to 20 as well. Are these the answers that you got? Good job, you. Now let's move on to another special position of estimation and approximation when the digit at the round off position is 9. Supposing we have to round off 5,964 to the nearest 100. Here, the digit at the round off position is 9, so the lower bound is 900. But what is the 100 after 900? 900 plus 100 is 1000. So the next 100 after 900 is 1000. So between 900 and 900, Between 900 and 1000 we have 950. So this is our middle value. 964 is to the left of that. That means is that the closest 100 is 1000. So in the initial number 5964, we will not replace 964 with 1000 and say we're going to write 5000 and 1000. This will obviously be wrong because you cannot approximate 5964 to 51,000. Instead, what we're going to do is that we're going to replace the 3 zeros here, 5964. We're going to replace the 3 zeros with 964 and then carry the 1 from the 1000, add it to the 1 here. We're going to have 6000. And that is why it is always better to start off your journey of approximation with the full number in mind. So imagine that we started off with 5964, then the lower bound will be 5900, then plus another 100, that will be 5900 plus 100, that is 6000. And so the middle value will be 5900, and between 900 and 1000 you have 950. That is the middle value, and then 5964 comes after that. So obviously that goes closer to 6000, and we say that the nearest 100 in this case is 6000. And you might be wondering, why 6000? Aren't we counting in hundreds anymore? Well, we're still counting in hundreds. 6000 is actually 60 hundreds. You heard me right, 60 hundreds. So we say 5964 is approximately equal to 6000. That is the way it is to be done. Let's check out the last example for the day. Suppose we have to round off 29.9 to the nearest whole number. This is an example straight from the lesson plan. Again, I would advise that you write out your number in full. The whole number position has 9 here, and so we're going to have 29.0 as the lower bound, 30.0 as the upper bound. Then the middle value will be 29.5. These are middle value. 29.9 is on the right side of that. Okay, so it is closer to 30.0. So we'll say 29.9 is approximately equal to 30.0, which you can cancel out the trading zero and say it's equal to 30. 29.9 is approximately equal to 30 to the nearest whole number. Alrighty then, today we have looked at a special case of approximation when the number to be approximated is exactly on the middle value of the upper bound and the lower bound. We can handle that in two ways. When it is the standard rule we are using, then we always round up to the upper bound. But when we're using the round off to even rule, we have to check the upper bound and the lower bound. Whichever one has an even number in the place value that we're considering, that is the one we round up to. We also looked at a case where the digit at the round off position is 9. And we said that the best way to handle that is always write out your numbers in full when you're writing the upper bound and lower bound. In the next lesson, we will look at estimation, how to calculate mentally quickly using your approximation rules, and also how to work with significant digits. See you then. Bye bye now.